All right, next example then. Here we go. New screen. Okay, we have next example. Where is my next example? Here we go. For example, x1 prime equals x1 minus 5x2, and x2 prime equals x1 plus 3x2. x1 prime equals x1 minus 5x2. x2 prime equals x1 plus 3x2. Got to do a check first. We need to check and make sure that we are allowed to use the eigenvalue method. Homogeneous, yes, all good, no problems. Constant coefficients, yes, all good, no problems. Homogeneous constant coefficients mean we can use the eigenvalue method. So I need 0 to be the determinant of lambda I minus a. That's going to be the determinant of lambda minus 1, positive 5. Careful with your signs. It's 0 minus negative 5, so positive 5, negative 1, and lambda minus 3. Can I assume that you can multiply out and we can get right to a polynomial of lambda squared minus 4 lambda plus 8? So do some FOILing, multiply that out. You should get to lambda squared minus 4 lambda plus 8. That's going to be your polynomial. Factor? Does that factor? Lambda squared minus 4 lambda plus 8? No, because I'm not nice. All right, so quadratic formula. And therefore, lambda equals 2 plus or minus 2i. Double check your quadratic formula. You can see what we're going to get there. We can use either. We can either use 2 plus 2i or 2 minus 2i. Doesn't matter. Either one's fine. Was going to go ahead and use lambda equals 2 plus 2i. If you want to use the minus, you absolutely can. But introducing more minuses into this process introduces more of a propensity to mess up. So I like using the plus. All right, so here's what we've got. We are going to have 2 plus 2i minus 1, 5, negative 1, 2 plus 2i minus 3. 2 plus 2i minus 1, 5, negative 1, 2 plus 2i minus 3. Can I simplify that, and can I also please interchange row 1 and row 2 at the same time so that I get a real number in the top left-hand corner, right? Remember, we want a real number in the top left-hand corner. That's going to make it easier to do our elementary row operations. So let me do both of those at the same time. This gives me negative 1 plus 2i, 1 plus 2i, and 5. Do we see that? Do we see where that's coming from? Switching and simplifying out? Okay. All right. So I want to get rid of the 1 plus 2i entry. That's the one I am looking to zero out. I have a negative 1 up here that's really nice. So I need to do 1 plus 2i times row 1 plus row 2 gets sent to row 2. 1 plus 2i times row 1 plus row 2 gets sent to row 2. And let's do a little bit of scratch work over here so we can see what comes up in the bottom right-hand corner. I am going to have negative 1 plus 2i times 1 plus 2i, right? That's the row 1 entry. So if we FOIL that out, we are going to get negative 1 plus 2i minus 2i plus 4i squared. I do some FOILing. And remember that I squared is negative 1, so that's the same thing as minus 4. And so that simplifies to negative 5. So that's the entry that I am adding to the positive 5 when I do 1 plus 2i times row 1 plus row 2 goes to row 2. So this is going to give me -1, -1 plus 2i, 0, and then also a 0. The 0 down in the corner is -5 plus 5. So I've got a 0 down there. Everybody good? Hanging with me on the algebra? All good? Yes. Okay, we're going to start a new screen. So remember, V1 goes with the first column and V2 goes with the second column, right? So I have -1 V1 plus 1 plus 2i, V2 has to equal 0. -1 V1 plus 1 plus 2i times V2 has to equal 0. We can pick anything we want, so let's choose V1 to be 1 plus 2i. I've got a 1 plus 2i in the second part, so choosing V1 to be 1 plus 2i will help me get rid of or kind of pair up with that V2. Then, fingers please, we should be able to do this with fingers. What does V2 have to equal in order to make that 0? Fingers for me, doing some math in your head. I am going to have, some people are showing me fingers. We've got ones, yes, 1. V2 is gonna have to equal 1 to make that work out. So V2 equals 1. All right, so my vector x is e to the 2 plus 2i times t. That's my e to the lambda t times 1 plus 2i 1. E to the 2 plus 2i t times 1 plus 2i and then 1. Gotta split with real parts and imaginary parts. And I'm gonna do something a little bit differently in this case. We're gonna take the e to the 2t and put it all the way out in front. So e to the 2t, instead of incorporating it into every single piece, can go all the way out in front. Then I don't have to write it 4 times, I can just write it once. And then we've got cosine of 2t plus I sine of 2t times 1 plus 2i, and cosine 2t plus I sine of 2t times 1. So I'm taking that e to the 2t and just throwing it all the way out in front. Okay, we're gonna need to FOIL in the top one. The bottom one's easy, it's just times 1, but the top one needs some foiling. So this is e to the 2t. Here we go. Cosine of 2t plus 2i cosine of 2t plus I sine of 2t plus 2i squared sine of 2t. FOIL. I don't think I wrote those out in the order that the letters in FOIL go with, but you get the answer. Cosine of 2t plus 2i cosine of 2t. Oh, I guess I did. Plus I sine of 2t plus 2i squared sine of 2t. And then the bottom one just stays cosine of 2t plus I sine of 2t. Okay, let's decompose into x1 vector and x2 vector. And this time we've got 6 pieces to divide up, right? 4 pieces in the top row, 2 pieces in the bottom row. So we've got 6 pieces to divide up. Cosine 2t, hold up fingers for me. Cosine 2t goes in x1 or x2? What do we got? Cosine of 2t goes in x1. Thank you. Cosine of 2t. Next part in the top row, part 1 or part 2, x1 or x2 in the second, in the next part in the, sorry, I can't talk. Next piece, top row, x1 or x2. There we go. 2, good. So 2 cosine 2t. Next piece, top row, x1 or x2. Next piece, top row, x2, thank you. So plus sine of 2t. Last piece, top row, be careful. Last piece, top row, x1 or x2 goes in x1, and it needs to be a negative, right? Because it's got an I squared. So minus 2 sine of 2t. bottom part's easy. I won't make you hold up fingers. Cosine of 2t and x1, sine of 2t and x2. Then, general solution, x equals c1 e to, well, actually, let's do it this way. Don't forget about that. I forgot about this. So in front of both of these, I need an e to the 2t, because that e to the 2t would need to distribute all the way through. So if you want to write it at the end and you have space there, that's fine. But don't forget about the e to the 2t in front of both of those. So then my vector x is c1 vector x1 plus c2 vector x2. I won't, but you could write little x1 of t and little x2 of t. So it would have a c1 and a c2 first line and second line. Maybe we'll just write little x2 of t so you can see it and it won't bother writing little x1 of t. So little x1 of t is c1 e to the 2t cosine 2t plus c2 e to the 2t sine of 2t. That's my little x2. Do we see where that's coming from on the second row of that vector? And then if you wanted to, you could rewrite little x1 also. It's just going to have 4 pieces and I'm running out of space and I don't have a whole chalkboard, so I won't bother to write it. Although by the time I'm done talking, I probably could have. So, okay. Questions? Anybody, anything? Process making sense. Laura, question, yes.
Could you go back to the slide before the one we were just on?
Yep. 1 second. Okay.
Okay, so for V2, I like, it's -1 plus 2i, but then.
Oh, I missed my negative. No, I'm fine. I think I'm okay. Keep talking.
Like, but on the next slide, we use 1 plus 2i. Like, am I just missing something? Or does that change anything?
Oh, fudge. No, I did it wrong. Okay, so here's what we're going to do. My answer is wrong. This should be a negative, and this should be a negative, and this should be a negative, and then that changes a whole bunch of stuff going all the way down. So don't bother to fix it, even though your answer is wrong, because it's going to be, thank you, I'm sorry, that is my fault. So yes, your answer is wrong, and you're gonna have to figure out where to distribute a negative through, and I should have checked that while I was working, and I did not. So the arithmetic in your answer is wrong. The basic process is still fine. So if you want to go back and fix it, and it's right in my notes have different values. I am sorry. Thank you for pointing that out. My bad. This is where it would be easier to see all of you in class and look at your confused faces and figure out that I did something wrong. I'm sorry. Are you okay fixing that on your own, or not fixing it and just saying, oops, sorry, the answer is basically the same and I have negatives that are off. My bad. Okay, high standards for online learning here. What else? Other questions? Other things that you're not sure of?
So if we were to write out x1 of t, would it just be c1 and c2, or would there would just be 2 c's, right?
It would be c1 and c2. So I can do it. Let me do it. I should really do it anyway. So here I'm going to go up on top because I don't have enough room. So x1 of t is going to be c1 e to the 2t times all of this. And again, this is wrong, but we're pretending that it's right. Cosine of 2t minus 2 sine of 2t. And then the second piece gets the c2. So c2, also e to the 2t, 2 cosine of 2t plus sine of 2t. So that would be your x1 of t.
Okay, thank you.
Good? Make sense?
Mm-hmm.
Okay. And again, that's wrong. There's a minus, there's a plus, there's stuff that isn't right. Sorry, my fault. Okay. Other questions? Other ones on this process? This is the perfect example of why you are in homework partners, because if you also screw up a negative, hopefully your homework partner will catch it before I have to try to catch it on the homework. So this is one of the reasons that Homework Partners are really, really good for this class, because there's so many little things that can go wrong, as I demonstrated today. I'm just trying to teach you things and failing. Okay, other questions? Anything else? Other ones that you have on this? All right, summarizing and looking at where we are going for next week. So we've dealt with distinct real eigenvalues. Yes, that was Wednesday. Today we did complex eigenvalues. We are missing case number 2, repeated real eigenvalues. That causes us problems, and that's what we're going to have to deal with on Monday and Tuesday next week. So that is the place that we are going. What happens if you have a repeated real eigenvalue? Sometimes bad things happen. Sometimes it's okay, but sometimes bad things happen, and we're going to look at both of those situations. Anything else for questions going once, going twice? Stuart, yeah.
I was just wondering if I could ask you a registration question after class.
After? Sure, I can stay on. Yeah. Anything else for differential equations questions? Bethany.
If we had done it with a negative, would we get the same answer, or?
I don't know, and I am unwilling to say yes or no at this point without writing out the details. Probably not, but that's not a guarantee. I'm not sure. I'd have to write it out. Anything else? Okay, so then if you didn't turn in your homework yet, by 2 o'clock, get that turned in, please and thank you. I will email out homework from 5.4. And remember, we agreed 5.4, 5.6 next week, Friday. That's when that stuff will be due. By Monday, I promise, I'm writing myself a note. I will have a list of topics for you beyond chapter 5 for the final exam. So that will be my by Monday. Okay, I am done. Stuart's gonna stay on to ask a registration question. Everybody else can sign off. Thank you, and see you on Monday.